Hey everybody, sorry about that. Little technical issues, you know, security folks, we touch computers, they break. It's what we do. I'm Reza Nikapor, this is William Green, and we're from Riot Games, and we're here to tell you a little bit about some of the things we do for our AWS. Quick little background about who we are, so context as to what we do at Riot. My name is Reza Nikapor again. I'm a security engineer there on the platform security team. Anywhere we deploy infrastructure, our team is responsible for securing.
And I'm William Green. I'm the product lead for platform security team at Riot. I've been at Riot for about two and a half years. Before Riot, I worked at SpaceX and the National Security Agency.
Yeah.
So at Riot, we aspire to be the most player-focused game company in the world. This is something that all of our engineers live by. Just to give you an example, if you guys remember the Poodle attack, you guys remember that from a few months ago, last year? Well, when the Poodle attack happened, everyone ran out really fast and patched all of their stuff, right? You guys all included? Well, we actually didn't, not right away, because if we had patched our stuff immediately, we would have impacted a ton of our players. We would have caused them what we call player pain. And it was really important for us to properly message and make sure folks knew that we were upgrading things and that they had to upgrade their browsers so they could support the better ciphers. In fact, just as another example, it's only been in the last couple months that we've stopped officially supporting Windows XP. Why? Because we have tons of players that use Windows XP. And same idea, we had to message and make sure that our players were ready for that kind of change. So that also trickles down to how we treat each other at Riot. Our team tries to make sure that everything we do is going to make the engineering teams, the game engineers that we work with, better. So in other words, the engineers at Riot are our players in security.
Yeah, and as William mentioned, we're player-focused, right? And what does that mean for us? It means being global. Our players are all over the world. And in order to meet our players everywhere, we need to have a global footprint to match that. At one point in time, we started with one AWS account, and now we've gotten up to over 100. And beyond that, we have offices, data centers, you name it. Anywhere on the globe where our players are, we're at. But to tell you the story of how we went from 1 to 100, I'm going to let William here chat at you for a bit.
So Riot's been using AWS for a really long time to help us scale. So initially at Riot, back in 2014, we thought it'd be a great idea to have one account, shared tenancy, let all the engineers be super agile and get all their things done in one account. How many people think that was a great idea or ended up really good? Yeah, it didn't end up really good, right? What happened was you had a ton of people doing really cool stuff, and we were able to iterate quickly. But we had this problem with shared accountability, right? No one really owned things, and you couldn't really figure out if you needed to open a port to allow data center access, like which port did you need and whose job was it to figure that out. And so basically when you have a shared account model like that, you have everyone owning everything. Well, no one owns anything then, and it was really hard. So we were moving quickly, but it wasn't working out too well. So after that, we began to shift toward a multi-account model. This got teams in charge of their own accounts. It let us hold teams accountable for the infrastructure that they were running and the security of that infrastructure. It helped tremendously with the accountability of resources. And this works because AWS doesn't charge us for how many accounts we have. They charge us by usage. So it was really easy to start scaling things out that way. So keeping infrastructure with different teams, that was working well. We have some good ownership. But the problem is now we have tons of accounts. How do we get those accounts all to have the same security tooling and configuration and all the logging going to the right place? Like that wasn't scaling for us now. So in 2018, we began to leverage as many AWS-specific features as we could. So in other words, we tried to match the complexity of our solution to the complexities that AWS allows us to use. So we developed a tool, maybe you've heard of it, Cloud Inquisitor, that went around, and one of the many things that it did was go around and enable CloudTrail logs on all the accounts and make sure that they were configured to go to our central account. That's great, but remember, teams own their accounts, so they have root on their account. So they could go in and remove that, And sure, 30 minutes later, Cloud Inquisitor would come back and restore that setting. But you can see this isn't really secure by default, right? Like this is something that people can undo. So, so now we use an organizational CloudTrail, which is great. That's enforced through AWS organizations. And now we can also lock down the accounts so that even the root account owners in those individual accounts, they can't undo some of the security tooling or the security settings that we've put into those accounts. So now we have a lot of accounts. How did we make all those accounts? Well, at first it was a manual process. And by manual process, I mean this might be the actual first time it's ever been documented. It basically involved a lot of people having a lot of tribal knowledge. An engineer would request a new account via email, usually. Basically, they would take their credit card, their personal credit card, and sign up for an account. And then we would move to consolidated billing. We would create the IAM roles and policies, configure our IDP. You could see this was a bunch of steps that were not well documented, not repeatable, not scalable. So we attempted to automate parts of this. We started using the account creation API, and we wrote a EC2 instance, or had an EC2 instance with a Python web app where people could go in, and it would go through and create the account, create the policies and rules. But this process was a little bit brittle. It didn't really automate everything. Like, it didn't link our account to our IDP. It didn't configure our security tools, all of them. It was still not quite what we needed to actually scale. So to get to full automation, we needed to start doing things that seems a little weird and a little far out there. So what we did is we leveraged a full serverless infrastructure that uses AWS step functions and Lambda functions to accurately describe the configuration that our accounts need to be secure before handing off to the account owners. So if you're not familiar with AWS step functions, this is what it looks like. All right, so the first thing that happens is we kick off the step function with some information like the account name, who the gatekeepers are, in other words, our owners. And then we kick off a call to the API that actually tells AWS to create the account. This takes a little bit of time, so that next function down there is checking the status. After that, we go into a parallel execution. We can execute a lot of these steps at once. And each one of those steps describes our infrastructure, describes the state of the account that we want to create. So, for example, one of them's creating a AWS enterprise support ticket to add it to our enterprise support. Sorry to the AWS person who got all those emails when we were testing that, sending the emails. It also adds account to our security tooling like Cloud Inquisitor. It adds it to all of our other tools. It creates the roles. And then let's talk about the IDP automation step. Now, our IDP actually doesn't have an API that we can call. So what we did was we took a headless Chrome browser and put it inside of a Lambda function so that it could reach out and actually click through the steps required in our IDP to get the stuff we need to wire up the IDP. And then the last step, it moves it to the proper OU. Now, all these steps are green, because this is an example that worked. But if any of these steps fail, they just turn red, and we'll get an email at the end of the process saying which step succeeded, or if everything succeeded, or if a step failed. And the great thing about step functions is we can just redo that step if for whatever reason one of those steps doesn't work. So the reason we can do this as well is that we have a trust relationship between our account that this Lambda runs into our organizational master account, and then also that master account can get down into that new account. So we actually run the Lambdas in the context of that account that we're creating. So that's a really important step there. So running through manually every time probably cost us a lot of money, but it also costs us a lot of time, the old manual process. But everyone on my team, I trust them to be able to create accounts. But I know that if it's 9 a.m. on a Monday and I haven't had my coffee yet, I would probably screw it up. So I'm sure everyone else feels the same way about that. So, and then when we looked at our semi-automated solution, that didn't cost us too much. And so switching to Lambda and step functions isn't really about cost. But it did save us over 90% by switching to lambdas and step functions. Well, 90%, $80 a month to pennies. So I guess that's 90%. But like I said, it wasn't necessarily about the money we saved, but it was about the time that we saved and the way that now our infrastructure is described in these Lambda functions that are Python, 40 lines of code each, and those step functions, and then the way that the step functions work completely describe a secure by default account at Riot. So to close things off on account creation, now our accounts are secure by default with all the configuration items that we need to make it part of our organization. It's a repeatable process, one where we have visibility into the account provisioning, so we can actually see what step it's on as it's working. All of our infrastructure is written as code now, and if we ever need to add more steps, add more security tools, they're just additional lambdas and step functions. So this solves one problem we were managing in our cloud infrastructure at scale. So with over 100 accounts, you might be asking, how do you allow developers to access all of these different accounts securely? So Reza's going to talk a little bit about that.
I know this one. So when you need to access hundreds of accounts, clearly the best way to do it is with permanent credentials, right? So access for AWS is described through their identity and access management system. And that enables you to describe entities in AWS. You can describe a user or a role. And these are individual entities that can take action, such as EC2 deploy instance, EC2 describe instance, whatever you got to do. And those roles and users are given their privileges through IAM policies. And the policy language is insanely strong, insanely complex. I absolutely love it. But what they do is you get permanent credentials, right? When you're a user, you get a nice set of static keys. You put those in your /AWS/credentials file. Maybe you put them in environment variables. Maybe you're working late, and they end up in your source code. Wait, what? When developers are working, sometimes they want to minimize as many moving parts as they can. So they might embed their permanent credentials in their application. They then hack away. It's 3 a.m. They're on their 18th cup of coffee for the day. Finally solve their problem. Git commit, git push origin master -- force. And now your permanent credentials ended up in public, right? And unfortunately, this happens to us. This happens to everyone, right? We are all security folks here, so it might not happen to us, but it happens to someone we know, right? But it happened at Riot. One of our developers working late committed permanent credentials into the public, and it resulted in an attacker grabbing 1,200 EC2 instances in our environment to mine Bitcoin. We're super lucky in this instance, right? If they had been an advanced attacker and they wanted to persist in our network, get a foothold in an AWS account, maybe try and root one of the computers are there, who knows what they could have done? We're very lucky that they just wanted Bitcoin from us. So this was hard, right? It was a bitter pill to swallow, and it really made us all sad. We had a difficult challenge, and we had to discuss how to solve it. So we were looking at various ways of providing access into AWS for our users. And one of the good ones we found was AWS STS, which is their secure token service. It enables you nowadays to generate temporary credentials into an account for anywhere from 1 to 12 hours, which is huge. And because of that, we were able to build our tool called the Key Conjuror. It leverages AWS STS. It's hooked up to our IDP, and it has multi-factor authentication requirements in order to generate keys. So how does this work out for us? Well, in 2017, we announced the tool to the organization, and we made it public. We said, hey, everyone, please, 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 we've built this new tool, and we'd like you to test it out. And you'll see we got 10% reduction in our total API keys, which is great. But when our goal is 0, 10%'s not like extraordinary, right? And we reached out to our users and we said, hey, what are we doing? What can we provide better for you in order to shift from your permanent credentials to this Key Conjuror service? And the biggest piece of feedback we got from our teams in 2017 was that 1-hour tokens don't cut it for us. I can't touch my phone for multi-factor authorization every time that I need to get AWS credentials, right? That's 10 times a day, maybe. You close your terminal, make it an 11th time, right? It became an unmanageable thing. And that was because in 2017, STS only had 1-hour tokens. There wasn't too much more than that. And so in 2018, when long-lived temporary credentials were around, we were able to see about a 73% reduction, right? We delivered 12-hour tokens to our org. We said, hey, Amazon gave us this. We're giving it to you. We want to enable you to be able to do your work. We also asked, please let us know why every key exists. We went through and scraped out every IAM user in our accounts. We scraped out every key related to those users. We then presented that to the org and said, hey, let us know why you have some of these permanent keys around. We know a few of these, like R Nikapor, right? Sounds like a user. We can probably delete that one and shift that user over to Key Conjuror. And again, we're not at 0 here. We didn't get 100% reduction. And the reason for that is that Key Conjuror solves the developer use case. And unfortunately, all our permanent keys aren't just for developers. We have services outside of AWS that need to be able to take whatever content they have, whether it's logs, updates to packages, whatever they need, and put it up or communicate with AWS. So we now went from a world where we had nearly 900 permanent API keys down to 250-ish, right, 230. And that was a huge reduction. That felt great. But one of the main benefits of that entire push was we now had a spreadsheet documenting every single API key in our environment and why they were there. So we went from a world of 900 keys without full knowledge to a world of 230, and we know exactly why each key exists. So how does Key Conjuror work? What's it made up of? There's 3 components. There's the API, the front end, and the command line tool. So the front end looks a little standard SPA, right? Single page application. Oh, crud, I forgot to black out. Oh, no, I'm just kidding. The credentials down there are temporary, right? They expired a few days ago. But this is the front end here. You just type in your 80 credentials. You request the account. You choose how many hours you want your tokens to live for. You click the request. You accept it on your phone, and you get credentials. But we all know developers don't use web browsers for anything other than Stack Overflow, and maybe Google to search Stack Overflow. So we had to bring a command line tool. And fortunately for us, the first iteration of our Key Conjuror command line tool was actually written by somebody outside of security. They believed in the idea of temporary credentials, and they came to us and said, hey, we built this command line tool. This is great. It really works out. Why don't you guys help share this out to the org? And since then, we've been able to see adoption of up to about 200 users a month. It's really, really nice. The API, oh, actually, sorry. This was the demo of how Key Conjuror works. So let's click the little play button. Cool, yeah. So, right, we start off on our command line, and we try to do some sort of action with EC2. And it's like, lols, dude, you don't even have credentials. So you go ahead and you type what you need, you accept your push, and then we'll dump creds to you. Apparently, I'm slow to accept my Duo pushes. But that's not really usable, right? You don't want it to copy and paste or pipe it into PB copy. So if you just evaluate it, we print everything that can be evaluated to your environment directly to standard out. And then as soon as you evaluate that, you can go ahead and run your AWS command a second time, and you'll see that you're able to get it. This is how our developers gain access into AWS from the command line when they need it. So what powers all of this? At first, everything was a long-lived EC2 instance. It was a Python app, running with a front end, all served from various Docker containers. I'm very much one computer, one purpose type of guy. So you see a container for the API, a container that serves the front end, a little bit of a caching. But this kind of infrastructure introduced problems that I wasn't solving, right? I had to deal with operating system management, Package management, making sure my EC2 instance is up to date. Oh, we hired a new member on our team, got to go ahead and rebuild the EC2 base image, then rebuild the key conjurer image so that way we have all the right SSH keys. Oh, somebody got offboarded? Well, great, now we have to rebuild it again. My deploy loop in this was about 30 minutes to make any small change and actually get it into a production environment. When you make accidents in your code, 30 minutes is a long time to wait until your user's like, hey, sorry, there's a bug. We can't do anything about it. It's building an AMI right now. So we hit the drawing board again, and I'm a huge fan of serverless. I think serverless is the bee's knees, my favorite tech since containers. And we went full serverless. So now the front end is served through CloudFront distribution backed by S3. So updates to my front end are 5 minutes at most if you hit the cache. If there's a cache miss, you get the fresh stuff right away. So now deploying my front end updates are only 5 minutes tops till my users get it again. With the API, we broke that out, same thing, custom domain on CloudFront, feeding into our API gateway backed by our Lambdas that run this. My updates here are 5 minutes, and most of that time's compiling, right? It's compiling and uploading to buckets and then running a Terraform script. So we went from a world of 30-minute deploys with OS maintenance, SSH key maintenance, all this stuff that wasn't solving my problem. My problem is delivering temporary credentials to Rioters, not maintaining operating systems. So we went from that to about 10-minute deploys. And it was huge. It works really fast. It's great. It was easy to see adoption from it. So these are our stats that we grab for a 30-day window. You'll see that we get about 2,000 key creations. We have approximately 175 users. This is great from 2017 when I used to pull up this board and I'd show my manager, I'd be like, hey, check it out. We had 16 users today, right? As soon as we got these long-lived tokens and we were able to deliver that, we saw just a huge uptick in our user base. And same kind of thing, right? Long-lived EC2 instance, about $80 a month, which is not insane, but when you can get a nice 90% cost reduction to going to $1 a month to run your infrastructure to provide temporary credentials to 200 people, that feels good, right? It's not huge savings that are going to take your entire team out to dinner for the next 3 months, but hey, you can get a nice lunch. So we went from a world with developers having 24/7 access to whatever AWS accounts they needed. If a laptop got stolen, we'd have to figure out, OK, where did this person have credentials? How do we rotate them? All that kind of stuff. Nowadays, we don't worry about that. Users don't have permanent keys. And the few ones that exist have strict S3 upload policies on the developer side. And then the other ones are service-based users, right? Or service-based roles. We can't really target those with the OSKey, or with the key conjurer application. And now 24/7, down to just when they need it. The same way that we believe in accessing production infrastructure, people shouldn't have unlimited access all the time, right? You only need it when you need it. And for this, what's really nice is limited blast radius. Someone pops one of these credentials, they leak out into the public, you won't be able to call IAM-specific actions, right? Most of our users don't have the ability to just spin up a new IAM user and attach whatever IAM policies they want. So these keys are very restricted in what they can do in the IAM space. So if they leak out, it's harder to get a foothold within one of our AWS accounts.
So we're really happy to announce today that you can go right now, well, not right now, wait till we're done with the talk. Go to GitHub and actually check out the source code for Key Conjure. We're making this open source today, and we're really excited for people to try it out. We've stubbed out the IDP part and the authentication part, so you can connect it to your own infrastructure, but everything else is exactly the same code that we use in our production environment.
Yeah, there's also some Terraform and stuff. If you have any questions or anything, please communicate with us through GitHub issues here, or chat with us afterward. We'd be more than happy to chat about it. But watching and starring our repo would be pretty cool. You could see our changes as we make them.
Yeah, we really think that if folks took this approach, that you can also see that huge reduction in permanent key credential usage, which represents a huge risk that you can reduce for your organizations.
Cool. Yeah. So for the future, William, what's happening with cloud accounts?
Yeah, so for cloud accounts, we're looking at continuing to improve like the overall customer experience. Right now, that whole step function thing still starts with an email sent to someone on my team. What we want to do is have a chance to create like a self-service portal so that the engineers can actually just kick everything off themselves. We also want to work with our teams that do the direct connects and the VPCs, kind of up the value chain on account creation. Because right now, at the end, you have an account, but it has just the default VPCs, right? There's nothing else inside of there. It's not connected to our data center networks or are connected to any of our direct connects. So we're going to work with those teams that do that on a regular basis to see how much we can integrate with their automation into this step function automation, continuing to describe our accounts as code.
The future for permanent credentials at Riot is targeting the service-to-service use case. When we can solve that, hopefully those last 250-ish keys we have can go away, and next year we can show you, hey, here's how we got to 0, right? So that's our big thing. We're still looking to stay in the serverless space, right? It's worked out very well for our team and the way we engineer. And the biggest challenge for us with this is that we want to drop in. We don't want to have to ask our developers, hey, can you just go reconfigure your entire CI/CD pipeline? I know that's like 5 minutes worth of work for everybody. It's super easy, I promise, right? So we have to figure out a way that we can deliver this value to our engineers without having to require a huge set of heavy lifting on their end. And that's the key piece right there that we're solving, and it's going to be a really fun challenge. Cool. So that's how we went from one account to hundreds, or 100 plus.
Yeah, hundreds. Yeah.
And how we went from our nearly 900 API keys down to 250. We reduced our attack surface. We actually have a repeatable, scalable process for creating accounts, and it seems like everyone in our AWS land at Riot seems to be pretty happy about the way it works now. Again, I'm Reza Nikapor. This is William Green. And if you really liked our talk, please tweet at our manager, Mark Hillick. That's his Twitter handle. Thank you all so much for coming out here and letting us chat at you about the work we've been doing. It's really
Make sure
appreciated.
to like and fork our GitHub repo. It's up, should be up now.